Hi everyone, and welcome to our video on graphing a non-shifted cosecant curve and a non-shifted secant curve. So we left off on our last video showing the basic sine and or cosecant and secant curves, where with cosecant we really just do sine and secant we really just do cosine. So we're going to continue that pattern even if they get more complicated with their numerical values. All right, so like on this number one, we're really going to instantly graph. Let's do it in blue. Y equals 3 sine of pi halves x. So nothing else changes, just cosecant we know is the reciprocal of sine. So let's get our sine curve first. All right, so this sine curve, the a value is 3, which means the amplitude is 3. So they might want that again. So I am going to box it. However, remember the sign with the a is more important. And then we have our b value, which is pi halves. This is where we go back to remembering. Okay, so in case you've done cotangents or tangents in between, here our period though is 2 pi over b, just like sine and cosine from the beginning. Okay, so we'll plug in the pi halves. So we have 2 pi over pi halves. And then I just multiply both top and bottom by 2, or whatever the denominator is. Right there, that small denominator, clean it up. Okay, so that means those twos cancel. And then up top, we have 4 pi. And down below, we have pi. And then the pi's cancel. Okay, and let me put it over here. Okay, so our period is 4 in this problem. All right, and then now we're going to sketch it. We're going to sketch our sine curve. Okay, so sine, and it might be good to do dashed lines because you are doing cosecant eventually, especially if you don't have multiple colors. But I would always recommend these multiple colors. Okay, so I am going to do it dashed. Okay, so I'm just do a dashed sine curve. And then let's get our important x values and y values. So we know the peak's at 3, the upper peak, and then we know the lower peak's at -3. And then we've got 4, 2, 1, and then 0, and times 1 by 3 to get 3. Okay, so that's the half times 3 technique still. And then now we'll go through and say, well, wherever it crosses the x-axis is where cosecant's going to have an asymptote. So we have an asymptote at x equals 2. We have an asymptote at x equals 4. And we have an asymptote at x equals 0. And then we'll finish off the rest of the graph by finding the peak and then drawing away from the sine curve. You get these U-ish shapes. Okay, so there's a little curve to them, and then they look vertical very fast. Okay, and then the other peak, and then draw away from the curve. There we go. Okay, so that's our final answer there. So the cosecant, again, it's 90% sine, and then last 10% is to finish off with the cosecant. Okay, so I'm going to box that. So in the black ink and the purple asymptote is the final answer, is our final graph. Okay, and like always, I mean, you could double check it. Okay, so for instance, if I plug in 3, so if I do y equals 3 cosecant of pi halves times 3, well, that would be y equals 3 cosecant of 3 pi halves. Cosecant of 3 pi halves is going to be -1. And then 3 times -1 is the -3 down there as the y coordinate. So it's looking good. And we could check the others as well if we want to. For instance, if we plug 2 in right away. So if I plug 2 in, I would have cosecant of pi. Cosecant of pi would be undefined, and that's where the asymptote is. Okay, looks good. Okay, number 2 though. All right, same deal. Let's do it in blue. I see, oh, it's secant here. So that really means do cosine. So 8 cosine of x over 7. And then if it helps, you can put a 1 with that x up there because that's going to be helpful with our b value. So we have a is 8, and the amplitude is 8 on our cosine curve. Then we've got our b value is 1/7. It's just the constant attached to x, or the coefficient with x. And then we'll do our period is 2 pi over whatever that value is, 1/7. And then this is also a fraction, so I'm going to multiply fraction and a fraction. So I'm going to multiply both top and bottom by 7. And that way the 7's canceled down below. And then 7 times 2 is 14. And then the pi is attached. Okay, so we have our period is 14 pi. All right, then we can now sketch our cosine curve. Okay, so cosine, just like before, it might be best to do a dashed line. Okay, so there's our cosine curve with a peak up top at 8 and then -8. And then the period's 14 pi, so we'll do 14 pi, half 14 pi to get 7 pi, half 7 pi to get 7 pi over 2, and then times this by 3, which would be 21 pi over 2. And we'll mark the 0 as well. Okay, so there's our cosine curve. All right, now let's wrap it up. We want secant. So we find those x-intercepts on our cosine curve and then draw in vertical asymptotes. And then we find our peaks on the cosine curve. And that's where the secant curve would have shared points. And from those shared points, we draw away from the cosine curve to the asymptotes. Like that. There we go. Okay, and now I'm going to box it and say, yep, that in the black ink is the secant curve. If it wants these labeled, we can label them. So x is 7 pi halves, x is 21 pi halves. Okay, so vertical asymptotes are x equals a number. So that's making them official. Okay, and then even again, like before, I can double check something. All right, so let's plug in 7 pi. I'm going to choose that. So if I do 7 pi, it would be 7 pi over 7. The 7's cancel. And we get 8 secant of pi. Well, secant of pi, do cosine of pi. Cosine of pi is -1. And that looks like, yeah, that matches the y-coordinate down there. It looks pretty good. Okay, so that looks good. All right, and we can check more if we need to. But I'm going to save time and say, we're done. Okay, so the next video is on a shifted one. Non-shift, which means we're just really doing a non-shifted and then doing arithmetic. Okay, so it carries over from sine and cosine. All right, but thanks for watching. If you have any questions, please let me know.